Hey guys, good morning all. Just give me a yes in the chat if you guys can hear me and see the sublime text. Quickly give me a yes in the chat if all of you guys can hear me loud and clear and see the sublime text. All of you can. Cool. Let's quickly start with the session. Prior to that, couple of things. Product of error except sir, that question is an assignment. That's why it's listed here, but I've seen it's already in the assignment, so that's why I'm not covering in the class anymore. And second thing is I'm currently on call. So in case there has to be a customer issue or something, I might have to switch back for a couple of minutes to my work laptop and then I'll come back. Although I don't doubt, or I hope at least it will not happen during the definition of this class. But in case it happens, just giving a heads up. Okay. All right, guys, coming back, let's have a quick revision. Where are we on DSA syllabus and then coming back to it. So on DSA syllabus, we have already covered about our arrays. We talked about the data structure part of it. We done some questions based upon the algorithm side. When I say algorithm side, we talked about linear search, binary search, prefix sum, some question related to sliding window, and today we'll be spending more time for questions specific to sliding window as well. Okay. With a couple of questions starting with decompress array, maximum subarray, sum, product of array except self, rotate array, so on and so forth. We also talked about XOR operations. We've done the questions based upon XOR operator and questions in general, and we also talked about the prime. So first we'll finish up the question that we have on prime, couple of questions, and then we'll move on to the sliding window. Now, quickly revising where we left off, we start with question number 10. Again, XOR based question, lead code 268, which is missing number. So basically you're given an array which contains n distinct numbers. Only one number is missing from that range. You need to find out what number is missing. So technically we should have n plus 1 values and we are given total values as n. One number is missing. We need to find what is that missing number. We have multiple approach for that. One can be a two nested loop. What I can do is I can put expected loop, which is from 0 to n, both inclusive. Current one value is missing. So I can loop an outer loop, I can run an inner loop, and I can compare if I equal to array of I. Time comes to big of n square, space comes to big of 1. Second, I can do the sorting and I can check, which can be based upon binary search. So I can reduce the complexity after sorting to log of n, but anyway, sorting will take n log n itself. Third is the XOR based solution, which is the important part here. Since I need to find one missing number, so everything else would be present, right? So if everything else is present, if I take a XOR value with the expected value, in that case, that will come out to be 0 because A XOR A is 0. And finally, only one number will be remaining, which is a missing number. So I'll come back to the code. I equal to 0, I less than an I plus plus. Answer of I equal to XOR of I XOR nums of I. So I'll take XOR of all the values. Time comes to big of n, space comes to big of n. Then we have sum and formula based approach. What is sum and formula based? I know that the sum of the expected number, which is from 0 to n, should be nn plus 1 by 2, right? So if it is nn plus 1 by 2, I'll take the current sum of the array. I'll subtract whatever is the answer, expected sum minus current sum. Time complexity big of n, space comp to big of n. Then we talked about the constant per se. If the constant become very large, for example, constant until it is 10 to the power 4, it's fine. My sum will still will be n square. So n square will be 10 to the power 8, which is within the range of integer. So it's fine. But if the constant become 10 to the power 6, 10 to the power 7, or even more than that, that is when I would have trouble. What sort of troubles I would have? Let's understand. If it becomes 10 to the power 6, 7, 8, it will definitely cross beyond the range of integer. So in that case, I have two options. Either I can define them as long, which basically is technically sacrificing my memory. Or if I don't want to do it, what's the other way around? The other way around is I found out and keeping it as still integer and still I should be able to pass. How will I be able to pass? The root cause here for going overflow is addition or multiplication, which is technically leading you to overflow. If somehow you can remove the part of addition and multiplication, that will reduce your overflow chances. So when we're calculating sum without using addition and multiplication, the idea is we can still do it. We can rely upon subtraction or division. How we can rely upon it? What do we need? Our requirement is not to calculate expected sum and then current sum and then take difference. The whole expectation is expected sum minus current sum. What is that missing number? Find it out. And these two lines are very important. Our goal is not to calculate expected sum or the current sum then take a difference. Our goal is just find that difference which is telling me the missing number. So what we can do? I will put the sum equal to n here because that is the last number I would have and rest number will be 0 to n minus 1. What I'm doing is I'm just putting I minus nums of I. So whatever value which is missing, that will give me the delta here and that delta is something I need. We did the errand for test case as well. Time comp to big of n, space comp to big of 1. Again, one of the most optimized solution. Then we moved on to question number 11, which is lead code 1720, which is decode XOR array. What does that question talks about? The question talks about is decoding a XOR array. So you're given original array, let's say something like this, and then you have encoded array. Encoded array will be, let's say, n minus 1 values. So out of those n minus 1 value, you're given the encoded array, you're given the first element of the original array, you need to find out the entire original array. So that is something we need to come up with. And that's the fifth property of XOR, which I purposefully did not talk about when I talked about XOR properties. What is this fifth property? If you understand the question is something like this. If I do A equal to B plus C, B will be A minus C. So subtraction is inverse of addition. A equal to B into C, B will become A by C, which is division is inverse of multiplication. So if I'm given encoded of phi equal to array of phi or array of phi plus 1, if I need to find array of phi, that will be something which is inverse of array of psi plus 1, right? So whatever that is inverse of XOR, I need to do with encoded of phi and array of phi plus 1. That will give me the answer of array of phi. Now the question becomes, what is inverse of XOR? And here comes the fifth property. The inverse of XOR is XOR itself. So if I have C equal to A XOR B, if I need to find A, it will be C XOR B, and which is equal to B XOR C, and same for the B as well. We verified that's with the code, works fine, and that's when finally move to the code part of it. So what does the code part says? You just need to calculate the original I. So original of I plus 1 will be equal to original I is or encoded of I. That's it. We already have the first element, so this will take care of it. Time comes to big of n, space count to big of 1. Then we move to primary test, which is another good example. We are done with XOR here. Then we move to primary test. What is primary test in general? As the name says, you're given a number n. You just need to check whether a number n is prime or not. That's what you call as primary test. Now, how do we call a prime number? What's the definition or baseline for a prime number? The definition is it should have only two factors, one and the number itself. So if I have to check if a number n is prime or not, let's see what is the most optimal solution we can come up with, starting with the most brute force. First thing first, I start with the definition. It will check for all numbers from 1 to n. I'll count the number of factors. Factors become 2, then it is a prime, otherwise it is not a prime. So I write down this function. If my factors become 2, I return true, otherwise I return false. Time comes to big of n, space comes to big of n. Then I continued with second, which is check for all numbers from 2 to n minus 1. If factors are between 2 to n minus 1, means it is not a prime, right? If there is no factors, means it is a prime. So we just reduce two iterations, 2 and the last element, and then we can compare whether it is prime or not. Time comes to again big of n minus 2, technically just two operations we reduce, space comes to big of 1. Third is to check for all numbers from 2 to n by 2. So for 2 to n by 2, what I'll be doing is, what is the intuition to go to n by 2 in the first place? The intuition is, if n is not a prime, its factor must lie between 2 to n by 2. So n by 2 is the biggest factor of any number which is not prime. So if I talk about this range 2 to n minus 1, if it has to have a factor, it should have a factor between n by 2. I explained that via the visual diagram on line diagram as well, right? So if there is a factor which is existing, at least one factor which is existing till n by 2, means there would be a non-prime number. If it does not exist, it is a prime number. So we check to n by 2, which is a significant improvement from the last time. Time comes will become big of n by 2, space count will become big of 1. Then we move to fourth, which is check for all numbers 2 to square root of n. And this is the most optimal solution to check whether a number is prime or not. Where does this intuition of square root of n comes? This comes from Euclid theorem. Euclid was a Greek mathematician. He pointed out that if any number does not have till square root of n, any factor till square root of n, it will not have any factor afterwards as well. For example, if I put n equal to 10 and I put square root of 10, which will be around 3.1868, I just need to compare between 2 till that part. If there's a factor, means it is not a prime. If it is a factor, means it is a prime, otherwise it is not a prime. So it has a factor, means it is not a prime. If I put n equal to 50, square root of 50 will be 7.182. So 2 to 7 I need to check. I'll see 2 and 5 both are less than square root of 50, means again not a prime. If I talk about 97, so in the case of 97, there is no factor of 97, again it becomes a prime. So we check till square root of n. You can write in either way, I've given both the condition. Time complexity big of square root of n, space complexity big of 1. Then we've talked about some of the people who like to hard code it. This is not an accurate answer. This will just provide you till a certain range. It will not work for any values of n. Then we talked about the fifth solution. Fifth solution is technically not a primary test. It is used for the range of values. We'll talk about it. What do you mean by range of values? This is something which we call as sieve of Eratosthenes. What is sieve of Eratosthenes? Eratosthenes, again, a Greek mathematician. The use case is not to check if a number is prime or not. The use case is you're given a range of values, L and R. You need to find out prime numbers between those range of values. And then you can do operations like addition, subtraction, multiplication, count something, etc. etc. Okay. So what do we need to do? We need to use Euclid theorem for finding prime. What is the approach technically does if you look at the code itself? I'm using the Euclid theorem to check if a number is prime or not. If it is prime, I'm marking all its multiple as false, right? That's exactly what we do. So first Euclid theorem, finding number in optimized time. If a number is prime, its multiple cannot be prime. So multiple of prime, we are just marking them as false. So this was the code that we have written. We run it and we get to know how it works. We still have to code it in lead code. So let's code it right away and then we can validate. That is something that we have done till the last part. Quickly give me clear if everybody clear with their revision. Any doubts, any questions, please let me know. Come on, guys, be quick. All good? Cool. Let's quickly code it out right away. We'll take this piece of code and we'll code it out right now. See what Destinies. Okay, let's go to lead code. Change this to Java. All right, this is a function that we have written, which is sleeve of Destinies. I'll just add static because we're calling it from a main function. What else? I'll remove this guy. And what do we need to call? Sleeve of Destinies. Let's call it for 10. This is printing for one time. That's printed for other times. We'll be calling this function. All right, let's run the code. What is the expected output? If I check for output till 10, the expected output should be 2, 3, 5, 7. We start from 2 and whatever factors that we can, or whatever prime numbers that we can find out, that will be 2, 3, 5, 7. Okay. What about the output of these two, 11 and 20? Quickly in the chat. What should be the output for 11? What should be the output for 20? Quickly in the chat. Come on, guys, be quick. Okay. So when we talk about printing all numbers till n, is n also covered? Is n also covered? Yes, then also is covered, right? It's less than equal to n. So n will be covered. So it'll be 2, 3, 5, 7, 11. And if we talk about 20, we'll continue. We have 11, we have 13, we have 17, we have 19. 20 is not a prime, so this will be the output. Let's run the code. Let's validate our output. Is our output correct? Our output is completely correct. Okay. So let's take this piece of code. We verified the output already. Come back here. And this guy. This is our code. And there goes our output. Okay. All right, guys, that was in the theory of. Okay, that was all in the theory of prime numbers in general, talking about all the 5 methods, including the sleeve of Rattlesnake, which is basically between a range of values. Now we are good to take the questions. We'll take only a couple of questions based upon prime numbers. As I said, pretty much 99% of the questions that you will face based upon prime numbers can be solved by C. 99% of them. Okay. All right, guys. That being said, let's quickly start with our 2 questions that we have on prime, and then we can move on to next topic, which is sliding window. So I'll take question 13 here, which is lead code. I think 208 or 204. I'm not 100% sure. We'll see. Count primes. So let's take count primes if we have. Yep, we have to do. Okay. In the meantime, I'll put it here. We'll wait for the problem statement to open, then we'll discuss about it. Okay, we're good. Let's talk about this problem statement now. This is lead code 204, which is given as count prime. As you can see, it is tagged as medium. Interesting part here. This is something interesting here. Although this question is pretty straightforward, out of 3 million submission, only 1/3 has been accepted. Almost 1/3 have been accepted, which is quite strange, right? Why it is strange? We'll talk about it. You're given an integer n, return the number of prime numbers that are strictly less than n. What do you understand by strictly less than n? Come on, guys. What do you understand by strictly less than n? Correct. Strictly less than n means not equal to, right? Completely less than n, not less than equal to n. So if I talk about n equal to 10, the output will be 4, which is 2357. If I talk about n equal to 11, what will be the output? What will be the output? The output will still be 4. Okay. N equal to 0, 0, n equal to 1, 0. That we already know. These are the edge cases. You'll understand why this becomes only 33 or 34% acceptance rate just right now. Okay. Example 1 is here. Explanation is here. Example 2, example 3. Pretty much straightforward question. Nothing much complicated about it. Just want to make sure that we have crystal clear understanding. N is given as 11. Output will still be 4 because 2, 3, 5, 7. 11 will not be counted. Simple. Okay. And if we talk about the function that we have to complete, this is the function that you have to complete. This guy. You're just returning a number of prime numbers from 2 till less than that number. Okay. And will not be included. All right, guys. Now coming back to it. Before I jump to solutions part and give you a time. This question looks straightforward, right? Which is pretty much a straightforward. You given integer n, you need to return the number of prime numbers that has strictly less than n, right? What do you think? Despite of such straightforward question, it has only 34% acceptance rate. What's your most probable guess? What's the reason that would have only such less acceptance rate, even though the question is so straightforward? Come on, guys, quickly in the chat. Do you see something in the problem statement which possibly can cause issues? It's right on the screen, whatever you need to find. Okay. The first thing that you need to look up is the constant. If I go with 10 to the power 6, will n square pass our test case? That's all you need to know. Okay. I want to try out this question, whatever optimized way that you can. I would say try with all the 5 approaches. We started with 5 approaches, starting from n, then 1 to n, then 2 to n minus 1, then n by 2, then square root of n, and then last the C1. Quickly code it out, which is anyways in your notes. You just have to copy paste the code, or you can just write down the code. It's not a big complicated code. And then let me know what kind of problems do you encounter. Okay. Any doubt in the question? Anything which is not clear in the question, anything you need my input on, let me know. If it is clear, just type clear in the chat. Guys, if the question is crystal clear, okay, all good. This is your lead code link, and this is the function that you have to complete. You guys know the drill. Directly go ahead on lead code, start submitting your solution. Once you guys are done, I would say try all the approach. It's not necessarily if you know the most optimized, you should directly code with the most optimized. Start with the brute force, see what happens, then let me know. Okay. Once you guys are done with the submission, share the submission link with me and change your message directly to me. Do not message to everyone. Your time starts now, and then we'll discuss. Let me know in the chat once you guys are done, then we'll have a discussion. All right, guys, I think enough time. I see some of the people were still coding, so I did not interrupt. But I think enough time. Let's start the discussion, then we can take it further. Okay. All right. How many of you are able to pass all the test cases? Just give me yes in the chat. Those were able to pass all the test cases. Few of you. Okay. Anybody who's still getting the TLE? Okay, cool. Let's discuss solutions. See, pretty straightforward. I have already told you about the 5 solutions. So pretty much sure if first 3 will give you the TLE, the rest 2 will pass definitely. Okay. Let's start with number 1, all the 5 solutions that we have. First solution will be big of n square. Why? What we have to do from 1 to n, we need to count the factors if equal to 2, which is strictly less than n, this guy. Okay. Second approach, all of you clear what is n square, right? For one number, we do n traversal, right? So if I have to do it from 1 to n, that would be big of n square. This part crystal clear to all. For one number to check whether it is a prime or not, you do big of n, right? So if you have to check for all the numbers, like whoever are prime, you have to do it from 1 to n itself. So it becomes a nested loop. 1 to n and then 1 to n, that becomes big of n square kind of code. Okay, Cool. Same will follow for the other approaches. So whatever the complexity of the file solution we discuss, multiply n by it because you have to do it for all n numbers to verify. So this will become big of n square, second approach as well. That is from 2 to n minus 1. Again, I'm talking about strictly less than n, but still won't make much difference. It will still remain big of n square. This guy, copy this, paste this here. What else? Next is n into n by 2, which was n by 2, but now we have to do for n numbers, so it becomes n by 2, which is from 1 to, or technically 2 to n by 2. Again, strictly less than n. Then what else? Then become n into square root of n. What is that? From 1 to n, I need to apply the Euclid theorem. And finally, it will be sieve of Eratosthenes. Okay. I believe with 10 raised to the power 6 constant, both fourth and fifth should pass all test cases. First three will give you TLE. First, second, and third, they will definitely give you TLE. Fourth and fifth should pass all the test cases. Okay. Let's look at the code real quick. Let's validate, and then we can continue. Here we are. This is count primes. Come back to the code real quick. This is the function that I have to complete. So initially, I initialize a variable integer, which is count equal to 0, the number of prime numbers that I want, which is strictly less than n. Okay, I'll have a look. Failing in the sense is giving you TLE. That's what you mean by failing. Okay. How many test cases are giving TLE? Is it just one edge case, two edge case, or multiple edge cases? How many of are passing? Let me ask the right question. Because I didn't code the fourth one, but n into square root of n with 10 raised to the power 6 should pass. Depends. I mean, square root of n can also go to 10 raised to the power 3. So there are possibilities depending upon what is the edge case. But anyways, 19 test cases are failing, I guess, right? Okay. Because 10 raised to the power 6, 19 is passing out of 66. Okay, then it is probably not the right idea. Because n into square root of n, that goes up to 10 raised to the power 6. And then into, if you take the square root, which will become 10 raised to the power 3. So 10 raised to the power 9, which will give you TLE, which makes sense. And I think the only solution is the fifth one. Okay. All right, guys, let's have a look at it. So this is count prime. So define integer count equal to 0, boolean of prime. I'm keeping whether a number is below. This is just a sieve of Eratosthenes code, nothing else, right? Now coming with this sieve of Eratosthenes code, what we have to do is we just, whatever the prime number is true, I need to return the count. So I increment the count, I get the answer. I compile the code, looks good. I submit it. Should be able to pass all test case. Yes, 66 test cases passed. Let's see the time complexity. N into log of n, which is fine, and space complexity, big of n, because we're keeping an addition array while we create a sieve of Eratosthenes, which is fine. All right, guys, this will pass all the test cases. Just a couple of things here. One moment. This is the code. Let me put the time and space complexity here as well. It will go to big of n, big of n. Okay. All right. Yeah, I'll explain the time complexity, but not in detail. But let's talk about it. Okay. Before that, this code clear to everyone? We just have implemented the code of sieve and passed all the test cases, nothing else. Everybody clear with this? Code, everybody clear? Approach, everybody clear? This is just a sieve code, so nothing changes in terms of approach. Okay. Now, in terms of complexity, that's where it becomes a bit tricky. How do we calculate this complexity? Let's talk about that. The complexity of sieve, how do we talk about log of n? Let's start with that first. It ideally comes from recurrence relation, but prior to that, I'll explain you how it theoretically happens, because we calculated via the master theorem, and with master theorem you can get the answer in just one formula, but I'll try to explain how theoretically it works. Okay, now understand, just remember the two things about what exactly sieve does. Number one, it checks whether a number is prime or not using Euclid theorem. And number two, whatever number is prime, its multiple times anything, I will just say at xk, which is constant, it cannot be prime. All agree? Here are the two parts of the CFR testing as we discuss in detail. Number one, check in the optimized solution whether a number is prime or not. Once a number is prime, its multiple can never be prime. These are the two things it does. Now understand this. Let's say I'm writing number from 1 to 50. So the ways this algorithm works, think of like in a sequential fashion or in a matrix, sorted matrix, 1, 2, 3, 4, 5, till whatever part. And let's say somewhere here it is 49 and 50. Okay. Think all numbers from 1 to 50 are written in a form of matrix, just to help you understand and visualize how does this algorithm actually works. So this is a matrix which is row-wise sorted and column-wise sorted and has the numbers written from 1 to 50. What we need to do is we need to find out the prime numbers between 1 to 50 range. Everybody with me so far? Come on, guys, be quick. Okay. Now, how does this algorithm technically works? How this algorithm works is, number one, it checks in the row wise, it checks in the column wise. So it creates an n cross n matrix. In that n cross n matrix, it is checking row wise, checking column wise. First thing that we do as part of the square root of n, what do? We find out the prime number. So 2 became prime number, 3 became prime number, 5 became prime number, so on and so forth. Second iteration. In second iteration, we find out the values which are not prime, right? Which are multiples of these prime numbers, we mark them as false. So how does it find is, it search in row wise, it search in column wise. So this guy being in a sorted fashion, this becomes log of n, and this guy becomes log of n. So total complexity becomes multiplication of this. So it becomes log of n. Okay. That is how essentially this algorithm complexity is calculated. If you want to understand it theoretically, that's why it's a bit tricky, but I try to explain in a very simple way how it works internally. If you want to check like how it mathematical log, just go to the master's theorem, put the formula for the iteration, it will give you log of n. Okay. But to visualize how the part of log of n come into picture, a matrix, row-wise and column-wise sorted, binary search implemented in checking for both the places. That's all. Okay. It's one of those algorithms where you cannot look at the code and tell the complexity, because if you try to look at the code and tell the complexity, most probably you would not be able to correct the right complexity, because from here, it is taking square root of n. This guy becomes big of n already. And from here, if you will calculate, it will become again less than square root of n, or square root of n by 2 or by p, whatever it is. So you won't be able to calculate the right complexity via the code itself. There are certain algorithms like that. It's not like you can always look at the code and tell the complexity. Sometimes you have to go into the internals how algorithm is actually working. Okay, it is one of those algorithms. That's why the complexity of n into log of log n. Okay. All right, guys, I'll clear this. Let me know if everybody is good. Then I can move on to next question. Cool. Let me write it here also. All right. Let's move on to next question, and which is the last question, which is a combination of two questions internally. So I'll say second last question technically, which is a really good question which has been asked in a lot of companies as part of their online assessment. Okay. I'll tell you the question first. The question was not asked as it is. I'll tell you what variation was asked, but before that, I'll show the question. Then we'll talk about it. The name of the question is sexy primes. And it's usually asked with the same name. So you might find a lot of articles discussing about this problem statement as it is. But let me open it real quick. All right. I haven't used CodeChef in years, so pretty much a new UI I'm seeing right now. But anyways, let's have a look. This is what the problem statement is. The problem statement is very simple, but in order to understand that, I would need to explain it. So I'll take some time to explain that, but I'll take the problem statement. These are the constraint. That's the name of the problem. Let's go back to Sublime. Let's talk about what this problem is exactly about. So we have a description, we have an input, we have an output, we have constant, single integer n, given number n. What else? 1 less than equal to n, less than equal to 100. I think that's what the problem is. Okay. First, let's talk about what is the question asking us, and then I'll talk about the variation which was asked in the interviews. So first thing first, a number is called a sexy prime if n is a prime number, n plus 6 is also a prime number. This line itself tells about the definition of sexy prime. A number is called to be a sexy prime if that number is a prime and n plus 6 is also a prime. Okay. Remember n plus 6, not n minus 6. What does that mean? If I talk about n equal to 5, is 5 a prime number? Yes or no? Come on, guys. Is 5 a prime number? Yes or no? Prime is 5 is a prime number. N plus 6, which is 5 plus 6, 11. Is 11 also a prime number? Okay. Since 5 is a prime number and 5 plus 6 is a prime number, hence 5 is a sexy prime. This part clear to all? 5 is a prime number, 5 plus 6 is a prime number, that's why it becomes a sexy prime. What else? N equal to 3. Is 3 a prime number? Yeah, coming to that. Is 3 a prime number? Yes, 3 is a prime number. N plus 6, 3 plus 6, which is 9. Is 9 a prime number? Is 9 a... Guys, 9 is not a prime number. 9 is not a prime number. So 9 is not a prime number. Hence, 3 is not a sexy prime. It is prime for sure, but it is not a sexy prime. Another example, n equal to 7. Is it a prime number? It is n plus 6. Prime number? N plus 6 prime number? Yes, it is. So does 7 become sexy prime? 7 becomes sexy prime. Why does this word of sexy prime, why does this part of difference of 6 comes into picture? And you can Google it. There's a Wikipedia page about it, so you can read more about it if you want to. But the reasoning comes from the part, if you look at the number of prime numbers, overall the prime numbers, and I don't know how many of you actually know about it. Prime numbers is not just a mathematical concept. Prime numbers is used in a lot of things. It's used in geometry, it's used in architecture, it's used in programming, it's used in defining the states of matters. Lot many other things prime numbers contribute to. So it's not something which is a mathematical concept. Okay. And technically everything originated from mathematics, but it's not just a mathematical approach, it is implementation. If you observe the prime numbers carefully, right, there are many prime numbers which have a difference of 6 constantly. That is why the part of 6 came into picture. That's why the term sexy prime came into picture. Okay. All right. Have a look. If I talk about 511, difference is 6. If I talk about 713, difference is 6. 1117, difference is again 6. 1319, difference is 6. What next? 1723, difference is 6. And 2329, difference is 6, and so on and so on and so forth. So with that definition, remember, if n is prime, n plus 6 is also prime, that is when you will claim that n is a sexy prime number, not n plus 6. So 5, 7, 11, 13, 17, 23, all of these are sexy prime numbers. This part crystal clear to all? Come on guys, quick in the chat. This part crystal clear to all? Okay. If this part is clear, now I'll divide the problem into two parts. I'll bring it here. There we go. Now we have clear with the concept of what is a sexy prime number, what number would be a sexy prime. Now I'll divide this question into two parts. Second part is what this question is asking. Let's start with the first part, then we'll move on to the second part. First part is count the number of sexy prime numbers less than or equal to n. So if I given a number n, you just need to count the number of sexy prime numbers which are less than or equal to n. Let's say if I say input 10, what will be the output? Quickly in the chat. For input 10, what is the output? Guys, it is count. Count the number. Output will become 2. Only 5 and 7 are sexy prime numbers which are less than or equal to n. If I talk about 20, what is the output? Come on, guys, 20. What is the output? Think it, guys. I'm getting different answers. Only one of the answer can be correct. See, have a look. 5, 7, 11, 13, 17. So total how many? 5. That is the correct output. Okay. The function that you have to complete is, let's name this function as whatever you want to call. Count of sexy primes, integer n. Okay. Let's start with this part. Requirement 1 clear to all. Question number 1, requirement clear to all. Okay. Let me give you the variation 2 also. Because once you're writing this code, I want you to write a code which is extensible enough, because I don't want to give you again time for writing the code too. So I'm giving you both the variations at once. Write a code with minimal code changes. It will work for 1, it will work for 2 as well. Okay. So that will save both of us time. For 20, it will be 6, 19 is inclusive. But 19 is not a sexy prime. 19 plus 6 is 25. 25 is not a prime. We're talking about sexy prime, not prime. Okay. All right. Why 2 is not there in prime list? It's not prime, it's the sexy prime. I just explained the concept of sexy prime numbers. Prime was in the sieve of Pareto's one, that is done already. We are moving to next question. Okay, sexy prime numbers. Cool. That was the first variation. Now the second variation, both the variation have been asked in interviews. The second variation, which is the actual question on CodeChef, this is the question which has again both of 1 and 2 have been asked in interviews. This is count the number of sexy prime factors less than or equal to n, or sexy prime factors of n. That should be the right term. This is what this problem statement is. If you look at this, number of sexy prime factors of the given number n. That is what the question was. Okay. Now with that being said, how will our output change? Let's have a look. What do you mean by sexy prime factors? It means 2 conditions I need to check. Number 1, that number should be a sexy prime. Number 2, it should be factor of n. Agree? When you say count sexy prime factors, so 2 conditions. It should be sexy prime, it should be factor of n. Now, can you tell me for 10, what should be the output? Guys, count. How many numbers are there? How many numbers are there which are sexy prime and which are factors of 10? There's only one number which is 5, and that's why my output becomes 1. Okay. Input 35. What's the output? Come on, guys, quick in the chat. 35, what's the output? How many sexy prime numbers which are also factors of 35? So we have 5, which is sexy prime. We have 7, which is sexy prime. So output becomes what? Output becomes 2, 5 and 7. Okay. These are the 2 variations of this problem statement. Everybody crystal clear with the 2 variations of this question. Number 1, count the sexy prime numbers less than equal to n. Number two, count the number of sexy prime factors of n. Anybody has any doubt, please let me know. Any doubt, anything which is not clear in the question, please let me know. If it is clear, just type clear. These are two different variations of this question. Okay, if everybody is clear, now this is what I want. That's the reason I covered both the variations here rather than giving you time after each. I want you to come up with the code, however optimized you want to make, you can make, feel free to do that. I want you to come up with a code which will work with minimal code changes for both the solution. It's up to you. You want to create a separate function kind of a thing, which you can call from both the functions, and you can make it work for both variations. It's totally up to you, however you want to implement. I need a set of code or kind of a code which with minimal variations will work for this variation, number one, and will also work for this variation. However you want to write it, totally up to you. However you want to modelize it, optimize it, totally up to you. All right, guys. Requirement crystal clear to all. Requirements crystal clear to all. I've given you sample input, I've given you sample output. That should be sufficient enough to test. Okay. If everything is crystal clear, I'll just change a message. I'll pass it over to you. You guys can start submitting the code. You can take it on lead code or wherever pattern that you want to make. Feel free to complete this wherever you want to, or even in your local editor as well. Do validate with the sample input output, then let me know. Okay. Goes without saying, change your message directly to me. Do not message to everyone. And once you guys are done, let me know. Then we can have discussion. All right, guys, enough time. Shall we discuss? Does anyone need more time? Let me know. If we're good to discuss, let's discuss more. Okay, cool. Let's discuss the code real quick. Pretty much we are going to use the same C of Fredosini's code. Nothing much we have to change. But let's see. What do we do? I'll take this guy. Copy this. Let's go to lead code real quick. Let's solve for both the variations here. Yeah. We actually don't need a different one. We can make with this one. All right, let's start with one by one. So what do we need here? Those count thing I'll remove later. Boolean's prime, this is fine. What do I need to check for sexy prime numbers? I'll define, just I'll remove it. This is where we need to define. Let's start with number of sexy primes. Number of sexy primes, and we start with 0. What do we need? I equal to 2, I less than equal to n, I plus plus. Prime of I is true. Apart from that, one more condition. Prime of I plus 6 is true. Okay. And since we have to do I plus 6, we need to make one more change. What is that? N plus 7. N is less than equal to n plus 7. Okay. What else? P is equal to fine. P is this. Should be good. And then what do we need to check? We need to check for this. Then I'll make number of sexy primes. And we'll print it. Okay. Actually, we can convert it into a function. There you go. Take all this logic. Static integer number of sexy primes, integer n. I'll paste the code here. This is fine. And I'll just call this function. Let's pass 10. Let's validate the output. Okay. And the code. One moment. I less than equal to n plus 6. Yeah, that as well. This guy p equal to p into p, I equal to p into p. That should become n plus 6 as well. All places. Anything else? This is fine. This is fine. This is n plus 6 as well. Okay. Actually, no, this should not need to be n plus 6. This needs to be till n only. So we are validating for the last values 2 to n. Return number of sexy primes. What did we get as the output? Nothing. Let's run it again. Okay. What did we miss? We are printing the number of sexy primes equal to this. Let me print this guy here. I'm not printing it, that's why. Okay. All right. For 10, the expected output is 2 and 5, which is 2, which is correct. What about 20? 20, it should be what? 4, I guess. Let's see. Oh, 5. We had how much? We had 5, we had 7, we had 11, we have 13, and 17. So 5. Okay. This needs to be changed to 20. 2 and 5, that should be the correct output, is the correct output. Cool. That is the first variation. Let's code real quick. There goes your variation 1. You got the output, which is 2 and 5. Now coming to variation 2, this is what I wanted. I want with the minimal code change, we can solve for both the variations. So let's solve for both the variation. P into P less than a K, I've already changed it. Not P into P, I will be less than equal to 6, right? That's already changed. Okay. All right, for the second variation, what do we need to do? Yeah, you can do it 6. I just put for 7 for including the last value as well. Because anyways, we're not using P as an index, we're using I as an index. So this is fine. Okay. All right, guys. Now coming to the second variation. What was the second variation? The second variation is we need to calculate number of sexy prime factors. Okay. So I'll rename this as number 1, number of sexy prime factors. Same for this guy. We have only one test case for this, which is 35, and the output should be 2. Okay, what should we do for this? I'll rename this, whatever the condition. What would be the condition? The condition would be, it should be a sexy prime. This is the condition for sexy prime. And then we have one more condition. What is that condition? It should be a factor as well. So n modulus I should also be equal to 0. That's it. You clear the console, you run the code, it should be 2. What is for 2? 5 and 7. Take this code, bring it back, 2 lines of code change, works for both functions. Okay. All right, guys. Everybody crystal clear with this? Majority of you have code in a similar fashion, so all good. We know about the time and space complexity as well. Everybody crystal clear with these two questions as well. Come on, guys, be quick. All good? Okay. If all good, we have roughly half an hour, actually more than half an hour. So let's quickly move on to our last topic, which is sliding window. We'll start with a series of questions. We'll take 2 to 3 questions on sliding window, and they are only sequential fashion. So start with easy, medium, and hard, or technically medium and hard. So let's move on to next part. Your prime related questions are done. These are pretty much the question that we'll find on prime. But anyways, coming back to what I said in the first part, majority of your prime questions, 99% of your prime questions can be solved by sieve of Eratosthenes. Even if you have looked at the problem statement we solved, sieve of Eratosthenes is all what we are using. Okay. So anytime a prime related question comes, be rest assured it will be solved by sieve of Eratosthenes. Okay. All right, guys, let's start with the sliding window algorithm. I'll quickly revise the theory. There's nothing much to add in the theory. If you remember when we talked about 2 pointers, pretty much we talked about sliding windows. I mean, that's it. Nothing else is required in the theory. Only the questions is what we are pending. We did a couple of questions there. Now we're going to do a few more. First thing first, that's something I covered before as well. Sliding window algorithm is a superset. Two pointers is a subset. These are not completely separate algorithm. These are superset and subset of the same algorithm. Be very clear with that. Okay. Repeating it again. Two pointer is also a type of a sliding window. Sliding window algorithm is a superset. Two pointer algorithm is a subset. Okay. What's the difference? Let's talk about it. I, J, and so on and so forth. Okay. So when we talk about sliding window, what does that mean is it can be any two random indices I and j. It is nothing to talk about. It has to be a begin or it has to be end, or they can move in a specific direction. When you say sliding window, any two endpoint will make a window, and between any two endpoint, you can move in either direction, left, right, whatever you want. So both pointers are movable in either directions. That is number one. Or fine. Number two, array can be sorted or unsorted. Two pointers has a limitation that it is working only on the case of sorted array. Sliding window has no such limitation. It can be unsorted also. What else? I and j, they can be any indices, not necessarily the first and last index. What else? What do you call the term window? So there are two parts, sliding and window. What do you call the window? Anything between I and j index is what you call as window. Okay. So this is my I, this is my j, anything in between, that is what you call as a window. Window can be of two type. One can be a fixed window, means j minus I. Let me answer here. Window can be of two types. It can be fixed or it can be variable, sliding, whatever you want to call it. When you say fixed window, means the difference of j minus I, it will remain constant. What do you mean by constant? Let's say this is 0 and this, oh, forget about this. This is 2, this is 5. Difference is 3. This will become 3, this will become 6. Difference still 3. This will become 10, this will become 13. Difference will still 6. Okay. That is what you call as fixed sliding window. Variable sliding window, or in general, when nothing is mentioned, it's always a variable sliding window. The difference is variable. The difference of j minus I. Okay. This is what you call a sliding window. So quickly revising, in the entire list of values, any two random pointers, if they are movable in either direction, there is no constraint. Values can be sorted, values can be unsorted, pointers can point anywhere, not necessarily only at the beginning, at the end, and they can move in either directions. This is what you call a sliding window. Now, that window can be of two types. Either can be a fixed size sliding window, or it can be a variable size sliding window. By default, it's variable size. When you say a fixed size sliding window, that means the difference between these two constraints, I and j, always remain constant. This part crystal clear to all. Understanding of sliding window. Come on, guys, quick in the chat. Okay. Now we talk about the subset of it. Subset of it is two pointers. So I'll start here. I here, j here. This is the start and this is the end. Okay. What do you mean by two pointers? Two pointers means both pointers are movable in nature. Number two, I will move from left to right only, and j will move from right to left only. So there's a restricted movement. They both cannot move in either directions. I will only move from left to right, j will only move from right to left. Array should be sorted because you apply two pointers only in the case of sorted arrays. What else? I and j, they have to be necessarily the end indices. Once you start your two pointers, you have to start with I pointing at the beginning, j pointing at the end. That is two pointers. So as you can clearly see, out of this superset, we provided some constraints and we make this as a subset. That's why I said Sliding window is your superset algorithm. Two pointers is your subset algorithm. Everybody crystal clear with this? Okay. All right, guys, if everybody crystal clear with this, then we can move on to next question. I'm going to take three questions based upon sliding window, and all the three questions are usually asked in the interview together. Okay. These are the kind of questions which, if an interviewer picks two or three questions, that is the kind of set they will pick up. If they have to complete a line on sliding window, they will ask first question. If you're able to solve it quickly, they'll move to second. If you're able to solve that as well, then they'll move on to third. But usually, majority of the people are able to solve first two only. But if you're really good, you can solve first two, then they'll move on to the third variation as well. Okay. All right. Let's start with the variations now. The last question was what? 14, I guess. Yes, 14. Let's move on to question number 15 real quick. So we'll cover them in sequence, and all of them are important question. All of them have been asked in really good product-based companies. Let's start with that. So I think I should have a list here. Yep, we do. These are the three questions that we'll do in sequence. And one of them is premium, so we'll go for lint code as well. So let's take this guy. Let's open it on lead code. And then we'll talk about it. This is lead code 485. This is maximum consecutive ones one. Okay. This has been asked in Google. Maximum consecutive ones. Okay. The link does not contain this. All right, we are good at the question. Let me quickly share my screen so we can have a look. Okay. This is lead code 485. If you come back to this is 2.6 million submissions. That's what tells you how much important this question is, 6.2 thousand likes. If you talk about the companies which have asked this question, it has been asked in Google recently quite a lot of times. When I say quite a lot of times, variations of that. Okay, not necessarily the exact question, but variations of that has been asked in many other companies as well. Okay, let's talk about the problem statement. The problem statement says, given a binary array nums, return the maximum number of consecutive ones in the array. Repeating, you're given a binary array. What do you mean by binary array? What do you mean by binary array? Correct. Binary array means only two values. Whatever it is doesn't need to be 0 and 1. It can be any two values, A and B or whatever you want to put. It will contain only two category of values. We need to find maximum number of consecutive ones. So if they mention 1, obviously it will be 0 and 1. So if we come to this 1, 1, 0, 1, 1. If you look at this, maximum number of consecutive ones. So where do I have consecutive ones? Let's talk about it. I got one set of consecutive ones here, which is size 2. And I got one set of consecutive ones here, which is size 3. So this guy is size 3, this guy is size 2. What is maximum out of this? The maximum is 3. That's why the output becomes 3. Okay. If we talk about 1, 0, 1, 1, 0, 1, I got this, which is 2, which is the maximum. That's why the output became 2. Everybody clear with this? Come on, guys, quick in the chat. This is a really good question. I mean, this is the easiest one. Then we'll go to medium one, then we'll go to hard one. Okay, these three questions are always asked in sequence whenever sliding window kind of question comes. Okay. All right, if we talk about constant given as 10 to the power 5, nums is either 0 and 1, which we already know about. 10 to the power 5, can you solve it in big of n square? You will not solve in big of n square. Okay, so that being said, let's come back. This is our sublime text. This is our problem statement. Consecutive ones is what we have to find. Input and output. Explanation, input, output, so on and so forth. Okay. And the function that you have to complete, let's talk about that. And you will learn a new technique about solving such kind of questions. But anyways, this is the function that we have to complete. So the function name is maximum consecutive ones. It's taking an array as an input, returning an integer as an output. Okay. All right, guys. Anything which is not clear on the question, anything which you want to clarify on the question, please let me know. Okay. Now some people are coding, that's why I was applying to them. All right. There is something which we want to learn as part of this, which will come up, maybe useful in some other questions as well, but rarely questions, but these questions are important questions which you will find such trick. Okay. The trick is called translation. What do you mean by translation? Translation means it has nothing to do with any algorithm, by the way. Translation means you get a problem statement, you translate it into something else which help you understand the problem better and solve it efficiently. Okay. What do you mean by that? Understand this. This is what is given in the question. Return the maximum number of consecutive ones in the array. This is what my problem statement is. Agree? If somehow I can understand this and I can translate into something which I am more familiar with or something which I'm more comfortable with, it will be much easier for me to write the code, debug it, explain it to somebody else, right? If I have to translate this, how would I translate this? I would translate this with a simple logic. Maximum number of consecutive ones, more or less, this is the four words that we need to focus on. Agree? When you say consecutive ones, what is something that remind of you? When you say consecutive ones, what's something that you have already learned so far and you can understand this is what consecutive means? Okay, what else? There's a very specific topic we talked about in consecutives. Anybody else? XOR, repetition window, closer but not accurate. Okay, there was something called not subset. There was something called subarray. Do you guys remember subarray versus subsequence versus subset? The first thing in a subarray was value should be consecutive. All remember? Come on, guys, quick in the chat. When we talked about subarray, first thing was it should be consecutive. In subsequences, it just needs to be in order, not consecutive. In subarray, it doesn't matter. Okay, or in subset, it doesn't matter. Then the second part becomes maximum number. So can I write this as find the length of largest subarray of 1 in a binary array? Yes or no? Is it the exact same question or not? Think about it, guys. This translation trick is very useful in a lot of questions. Only thing that I have done is I have taken these consecutive ones get converted into subarray. Maximum number got converted into largest. That's it. These are the two things that I have done. So return the maximum number of consecutive one. Technically, it becomes find the length of the largest subarray in a binary array. That's all I need. Okay. Now coming to this part, once we understood this translation, why did we do it? What's the advantage of it? The advantage is two things. We are very familiar with the concept of subarray, and it becomes much easier to solve the second variation rather than solving for the first variation. Because what do we need to do to find the largest subarray of 1 in a binary array? I just need to use one thing. What is that? I'm going to use a variable answer to find largest subarray of 1, and I'll put a condition. If array of I is 0, I'll reset my answer to 0. Else, I will do answer plus plus. All agree? There are only two values, 0 and 1. So till the part I'm getting 1, I'll continue it. Till the moment I get 0, I'll reset it. Yes or no? And my final answer would be max of all answer. Why it should be max of all answer? Because there can be multiple subarrays. Subarrays of 1. And we need to find the maximum out of it. Okay. Let's do a quick try run to understand that. Then we'll talk about it. Okay, let me explain again. The statement that we have picked up, or the question that we're technically solving now, is length of the largest subarray of 1 in a binary array. How did we get that? I already explained. Okay. Why this become much easier to solve? Because if I have to calculate the length of largest subarray of 1, I just need to keep one variable which will be denoting the length, right? Two possibilities are there. Since it's a binary array, values will be either 0 or it will be 1. So if I continue from my current position, next value is 1, right? Then in that case, I'll just need to increment it. If the next value becomes 0, then I need to reset it because only 0 and 1 will be there. So till the time you're getting 1, continue it because you are in a consecutive subarray of 1. The moment it becomes 0, that is when you reset it. And coming to the last part, why do you need to calculate maximum of all? Because there can be multiple subarrays. For example, if you take first test case, this is first subarray, the count will be 2. This is second subarray, the count will be 3. So I need to keep the maximum of it. Everybody clear with this? Quickly in the chat. Come on guys, be quick. If this is good, let's do a quick dry run and then we'll move on to the code part. Okay. Or if we can't discuss the code today because we're pretty much on time, we'll discuss it tomorrow. Nothing to worry. Approach at least we should be clear with. What is the approach? We start with 0. Okay. And we just move from left to right. Two things. If it is 0, you keep the answer 0 or you reset the answer 0. Otherwise, you do answer plus plus. So I start with this. This guy is what I start with. Will I answer change from 0 to 1? Yes or no? The first element. Will my answer change from 0 to 1? Yes or no? It will. 0 to 1 because I got the first value as 1. Continue. Now you move to next, second value. It is 1. So what will I do? I'll change from 1 to 2. Yes or no? Come on guys, quick in the chat. Second value is also 1. So I'll increment 1 to 2. Next, I come here. Now what will I do? I encounter 0. What will I do now? Correct. I will reset my answer to 0. Next. Next value is 1. What will happen now? 0 will change to 1. Next. 1 will change to 2. And finally, 2 will change to 3. No, we did not lose anything. We did not lose anything. I'm telling the approach. Finally, 2 becomes 3. Okay. So what will be keeping? We'll keeping a logic something like that. Final answer. Whatever the maximum value we have got out of 2 and 3, that will be our answer. This is the approach I was talking about. Everybody clear? It's a very straightforward solution and it becomes so straightforward because we have technically did the translation. If you start solving from the first one, you might get confused. I'm not saying it will not be solved, but you might get confused. But if you solve in this variation, now the question becomes very simple, very straightforward to implement. You need to find the largest subarray of 1. In a binary array, you just keep one variable and then you keep on put two condition. If it is 0, you reset to 0. If it is 1, you keep on continue. Okay. The only thing that you have to take care is since you have to maintain the maximum because there can be multiple subarrays, you will need to maintain a maximum. No, you don't need to maintain an array. We can do it with one variable. There is no array required. Space comes to big of 1, time comes to big of 1. This question can be easily solved. We do not need to hold an array. Okay. With one variable only, we need to do. Understand this. Whenever and make it a rule in thumb rule in programming, store only the values where you need to do manipulation on top of it. Okay. Am I doing any manipulation on 2 or 3? No. I'm just reading. It's not a write call. It's not update. It's just a read call. So if I'm not doing any update, there is no need to store it. I just need to know which is the maximum. That's it. Whatever is the maximum, I'm getting the answer. That's all I need. I don't need to store all that. Storage is only once you have to update something. If it is not required, don't store. As simple as that. Okay. All right, guys. This part clear to all? 11011, the answer will be 2, but actual answer will be 3. No, it will work for all test cases. You can validate that. Let's go to the code. I didn't want to because we're already about time, but let's go through the code. It's hardly 2 lines of code, won't take much time. Cool. Let's look at the code real quick. Here we are. I'm just going to present it here. There we go. One moment. So if you look at this, all I'm doing is I've just make a simple nested. One moment, guys. I'll just make it a simple if else condition here, which is ternary operator. You want to do by if else, feel free to do that. I preferred it in an optimized way. That's why I put a ternary operator. So what are we doing here? We define answer equal to 0, result equal to integer dot min value. Since I'm keeping a max here, look at the condition I'm checking. If value becomes 0, I put the answer equal to 0. Agree? If value becomes 0, value is the current value I'm passing in the array. If value is 0, I put the answer equal to 0. If it is not 0, I increment the answer as answer plus 1. All agree? Come on guys, quick in the chat. And three things I'm doing here. One is if, second is else, third is max. And what I'm doing is I'm just comparing the maximum of result and answer. So whatever is the maximum answer you have got, store it in the result. So first answer you got 2. So your result store into the result, which becomes 2. Then you store into the answer 3, which result will become 3. That's it. So I don't need any array to store these values. All I'm comparing is whatever is the maximum value so far. That's it. One line of code change. Everybody crystal clear? Okay, cool. That's it. That's how we return the answer. Time comes to big of n, space comes to big of 1. Let's quickly compile it. Let's submit. All right, pass all test case. It usually defeat 100%, but that's fine. It's running on a heap bucket, so fine. O1 time, O1 space, pass all test cases. Okay. Somebody asked a good question. How it is a sliding window? See, understand this. Pretty much all the operation that you're doing is a sliding window. When you're traversing an array, what exactly you're doing? You are defining which window do you want to move. So even if you're moving by one step, that is also a window. Doesn't need to be by necessarily two variables. Okay, so that's why it qualifies under sliding window. All right, let me take this. We're good. Back here. There we go. This was the easy variation. Now we have a medium variation and hard variation, which we'll discuss in tomorrow's session. Okay. So we'll finish the sliding window in tomorrow's session. Then we'll move on to next topic, which is linked list. Anyways, let's quickly revise what we discussed as part of today's session before wrapping up. So we made a good progress. This guy, I'm marking it as done. I'm moving that to do to later. This is something that we'll start with tomorrow. Okay. Now, quick check. First thing, we talked about the sieve of Eratosthenes. We implemented the solution in lead code. We verified the output, works fine. Then we solved question number 13. One moment. Question number 13, which is lead code 204, which is count primes. So in terms of count primes, what did we talk about? We talked about different solutions, and we know that till part 4, it will not work because the constraints are very high. That's why even though it's a simple question, none of these 4 solutions work because of higher constant. We have to code for sieve of Eratosthenes. So we write down that code, we passed all the test cases, we talked a bit about time and space complexity as well. Then you move to question number 14, sexy prime. This is technically 2 questions. We validated first the 2 questions. First variation is we need to count the number of sexy prime less than equal to n. So again, sieve of Eratosthenes code, minor modification, and we got the answer. The definition of sexy prime, if n is a prime and n plus 6 is also a prime, that is when you say n to be a sexy prime number. Second variation of this question, we need to calculate the count of sexy prime factors of n. So just one more condition I need to add. It should be a sexy prime and it should be a factor of n. So that condition we have added. Time complexity, space complexity, we already discussed about in sieve of Eratosthenes. Then finally move to the sliding window algorithm, but revisited the theory that we already discussed as the time of 2 pointers. In sliding window, both pointers move in either directions. Array can be sorted, unsorted. I and j can be n indices. Difference between fixed versus variable sliding window we talked about. 2 pointers, there are constants because both pointers are movable in nature, but there's a specific direction they move in. So I move from left to right, j move from right to left. Array should be sorted. I and j should be the necessarily n indices. Then question number 15, which is lead code 485, maximum consecutive ones, which has been asked in Google. We solved that. Here's the important thing that we learned today, which is called translation. So a given problem statement can be converted to a problem statement, which will be easier to understand and implement for you. Okay. So we write down the code for that. We talked about approach. We talked about the solution, so on and so forth. Okay. Then we did the errand for this. We got our output, time compass to big of n, space comp to big of 1. Okay. All right, guys. Everybody crystal clear with today's session? Everybody crystal clear with today's session? Okay. If everybody's clear, let's talk about the next part. Okay, I see one question. How to explain sieve of Eratosthenes during an interview? You don't need to. Majority of the interviewers will already know about sieve of Eratosthenes. It's very clear that if somebody is asking that question, they would not be aware of. You can mention the algorithm, it's Siva Fretastonys, and then if they ask you about how did this approach come, although nobody asked it, to be very honest, so you don't have to go into the basics of it came from Euclid theorem and stuff. Majority of the interviewers already know about Siva Fretastonys, okay? Or you can talk about it's a concept of Siva Fretastonys. Next topic would be linked list, okay? If we declare the maximum integer min value, it will fail in one edge case as 0. One edge case as 0. So we are assuming here at least one answer would be there, right? Because we talked about binary arrays. So the edge case we are talking about is if I initialize with 0, that case will never exist. Why it will never exist is if we talk about it's going to be a binary array, right? So in the binary array, at least I'm assuming one value should always exist. That's why it passed all the test cases, right? At least one value should always exist. So if at least one exists, in that case, the output will never be 0. Okay. Although considering the length, just passing as array 0 is also a valid input. In that case, yes, we will not get the correct answer, but that being said, it will never happen. Okay. All right, guys. That being said, let's wrap up the session here for today. Let's catch up in the next session, which is tomorrow. Then we'll continue from there. Okay. All right, guys. Thanks for joining in. Have a good one. We'll catch up tomorrow.